Today, I learned a cool fact about peanut butter, and now the mining companies are coming after me. Picture this. You're in your kitchen, spreading peanut butter on toast, and just in that moment, you remember, oh right, I needed to get a ring to propose to my girlfriend. Luckily for you, in this one very specific and unlikely situation, you, with your peanut butter and spare high pressure, high temperature press, which I know you have, can get out of this jam. It sounds ridiculous, but it's true. Scientists have actually made tiny diamonds from peanut butter in a lab. It's not magic and it's not fake, it's pure chemistry and physics. The same processes that happen deep inside the Earth's mantle. So today, we're diving into how this works, why it's possible, and what it tells us about the weird and wonderful ways matter can transform under pressure. However, before we get to peanut butter, let's start with diamonds themselves. A diamond is one of the most famous substances on Earth, rare, valuable, and incredibly hard. But under all that shine, it's just carbon, the same element in charcoal, pencil graphite, and even in your own body. What makes a diamond special is not what it's made of, but how those carbon atoms are arranged. In graphite, carbon atoms sit in a flat sheet that easily slide off each other. That's why graphite feels soft, and you can literally rub off layers when you write with a pencil. In a diamond, though, every carbon atom bonds to four others in a tight, three-dimensional lattice, like a super strong molecular scaffold. That structure gives diamonds their legendary hardness and clarity. Same element, different arrangement. Totally different properties. So then, where do natural diamonds come from? Well, they're born deep within Earth's mantle, more than 150 kilometers below your feet, where carbon atoms experience unimaginable pressure and heat. The temperature down there can reach 1500 degrees Celsius, and the pressure is over 5 gigapascals. That's 50,000 times the pressure at sea level. Under those extreme conditions, carbon atoms rearrange themselves into diamonds, unique structure. Then, through volcanic eruptions, diamonds are carried to the surface by magma in narrow vertical tubes called kimberlite pipes. That's how the diamonds we mine today got there, pieces of ancient carbon brought up from the deep earth. Scientists realized if the earth can make diamonds naturally, maybe we can play nature a little bit and influence it. That idea led to an invention of synthetic diamonds in the 1950s. The process is called HPHT, short for high pressure, high temperature. In an HPHT press, scientists take a tiny amount of carbon and squeeze it between anvils until the pressure reaches over 1,000,000 times that of Earth's atmosphere. Then they heat it to 1500 degrees Celsius. It's like creating a miniature version of Earth's mantle in a lab. Under these conditions, the carbon rearranges itself into diamonds, the same way it would naturally underground, but much, much faster. Now here's where peanut butter comes in. Although it doesn't have the rarity, value, or hardness diamonds do, what it has in abundance is organic carbon compounds. Things like fats, proteins, and sugars. Those molecules are mostly made of carbon, hydrogen, and oxygen. So, if you strip away the hydrogen and oxygen, what you have left is a lot of carbon that smells like nuts and would give 3% of people a trip to the ER. So theoretically, you could extract the carbon from peanut butter, compress it, and rearrange it into a diamond lattice. And yes, scientists have actually done this. In 2014, a German geochemist named Dan Frost from the Bayerische Geo Institute tried using peanut butter in this experiment. He studies how materials behave under the extreme conditions found deep inside planets. When Frost placed peanut butter under HPHT conditions, the carbon atoms restructured into tiny diamonds. They weren't large or gem quality, but they were real crystalline diamonds made from actual peanut butter. So now that you have your peanut butter and HPHT press plugged in and ready to go, how do you turn peanut butter into diamonds? Step by step. First, the peanut butter is dried and purified. Since excess water or oil can explode under pressure, the goal is to isolate as much carbon-rich material as possible. Next, that carbon is placed inside an HPHT device, and that carbon slowly rearranges into diamond crystals. It's not instant, the transformation can take hours or even days, but once complete, scientists can recover microscopic diamonds from the sample. But as cool as it sounds, there are a few big problems. First, peanut butter releases a lot of hydrogen gas during the reaction. Hydrogen is extremely light and reactive, and it can damage the delicate instruments inside the press, and with a little spark, even outside the press. Second, the diamonds produced are tiny, smaller than a grain of sand. And finally, the energy cost is enormous. You'd spend far more money generating the required heat and pressure than the resulting diamond would ever be worth. So while it's technically possible, it's definitely not practical. However, you forgot to buy a ring, so practicality is kind of out the window. Luckily, HPHT isn't the only way to grow diamonds. Scientists have also used a method called CVD, or chemical vapor deposition. Instead of crushing carbon under pressure, CVD grows diamonds atom by atom in a chamber filled with carbon gas, usually methane. The gas is heated into a plasma, which breaks apart the methane molecules. Carbon atoms then settle onto a surface, forming diamond layer by layer like molecular snow. This process is slower, but more controlled. It allows scientists to make large, high-quality diamond films used in electronics, optics, and jewelry. And yes, in theory, you could vaporize peanut butter, separate the carbon, and feed that gas into a CVD chamber. But again, it's an expensive, complex process, prone to blowing a hole in your roof. So if it's so impractical, why bother? Dan Frost's peanut butter diamonds weren't made to impress jewelers. They were made to understand how carbon behaves under extreme conditions, like those found inside Earth's mantle or even other planets. By experimenting with materials like peanut butter, full of complex organic compounds, scientists can observe how elements like carbon, hydrogen, and oxygen interact and transform under pressure. This helps us model how planets form, what minerals exist deep inside them, and even how carbon might behave on massive worlds like Neptune or super Earth exoplanets. Could we ever make peanut butter diamonds on a larger scale? Technically, yes, but the cost would be astronomical. To produce even 1 carat diamonds, you'd need huge amounts of energy, complex machinery, and perfect control over pressure and temperature. Also, just like so much peanut butter. In the end, the peanut butter to diamond experiment isn't about making gemstones. It's about understanding the transformative power of pressure and heat. It reminds us that the same atoms that make up a simple snack can, under the right conditions, become one of the hardest substances known to science. That's chemistry's great secret. Structure defines everything. Rearrange atoms, and you change reality itself, turning something soft and sticky into something clear, hard, and brilliant. So, next time you open a jar of peanut butter, take a second to think about it. Hidden inside that creamy spread is the same carbon that forms stars, planets, diamonds, and even you. All it takes is unimaginable pressure, a little heat, and a lot of curiosity.